Hello and welcome to my YouTube channel. This is Dramani Online Mathematics. Today we are going to look at length of an arc, area of a sector, and perimeter of a sector. Length of an arc, area of a sector, and perimeter of a sector. So let me have this here. Now when we say arc, what does it mean? Arc is just a portion of a circle or the circumference. Okay, so when, let's say, from here to here is an arc because it's a portion of the circumference. Now we also have area of a sector. Now what do you mean by area of a sector? Let's assume that here is the center. So there's an angle from here, theta. Now area of a sector is area bounded by two radii. You know, from the center of this circle to the circumference of the circle is a radius, right? So here too will be a radius. Two radius or more is radii. So the plural form of radius is radii. Now, when we have area like this bounded by two radii and an arc like this, then we can say that that is what? A sector. So a sector is bounded by two radii and an arc. Is that okay? Very good. Now, let's look at how to get the length of an arc. So let's say if I want to get the length of this arc from here to here, let's name it A, B. Okay. What you are going to do is that, you know that for a circle normally sum up to 360. So we can have the angle there in the ratio terms over what? 360 degrees. Is that okay? Very good. And you know, since one is a portion of the circumference, so let's represent the length of an arc by L. And it's a portion of the circumference, it will be L over what? The circumference. Is that okay? But circumference is given as 2 pi r. So in this case, we are going to have L over 2 pi r equals theta over 360 degrees. Is that okay? So when I do cross multiplication, but all I need is that I want this 2 pi r come here, so I can multiply both sides by 2 pi r. So that if I do that, 2 pi r times L over 2 pi r is equals to theta over 360 degrees times 2 pi r. So that this will cancel this, meaning that my L is equals to theta over 360 degrees times 2 pi r. Is that okay? So the formula for finding an arc of a circle is L equals theta over 360 degrees times 2 pi r. Is that okay? So that's the formula for finding that. So theta over 360 times 2 pi r. So when they ask you to find the length of an arc, this is the formula you are going to use. Is that okay? Now let's also look for the area of what? The sector. The area of the sector. So now let's look at the proof for the area of a sector. So you have looked at the length of an arc. Now you are going to look at the area of a sector, the formula for that. Just like what I did for the length of an arc. We know that the area in a ratio form, the area will be A over what? Pi r squared. Is that okay? Which is equals to the angle form over the 360 degrees. Meaning that my area is equals to theta over, okay, let's go this way. You know this A over pi r squared equals theta over 360. So you can find LCM. I mean, I can multiply by the pi r squared because I want the area to stand alone. So that I'll have pi r squared times area over pi r squared equals theta over 360 degrees times pi r squared. So meaning that this one cancels this. I have my area equals theta over 360 times pi r squared. So that's the formula of finding the area of a sector. Area of a sector. Now, if I want to find the perimeter of a sector, you want to find the perimeter of a sector, it is very simple. You see, the perimeter of this sector will be this, from here to here, this place, and from here to here. Is that okay? Meaning that the perimeter of the sector is going to be r plus the length of an arc. Is that okay? So that is going to give us 2r plus the length of an arc, which we have already looked for, is theta over 360 times 2 pi r. Is that okay? So here you can factorize 2r out, leaving 1 plus theta r over 360 theta pi over 360. So this one becomes the formula for the perimeter of the sector. So formula for the area of the sector, formula for the perimeter of the sector, and the length of an arc of the sector was given as theta over 360 times 2 pi r. So length of an arc, the perimeter of the sector, and the area of the sector. Is that okay? So we are going to look at how to apply this to solve question. But before I do that, remember that this one is the minor sector. We have the major sector. So assuming that you have to find this place, you simply subtract this one. Let's say we have given you this place. Let's say 60 degrees. And you want here, you subtract 60 from 360 to get 300. So in place of the theta, you place what? 300 there. That's when you are finding the major sector. Is that okay? So you are going to look at examples. Okay, so now let's look at our first example of this. So the area of a circle with center O is 120 centimeters squared. So in this case, the area has been given, right, of the circle. Then the angle AOB is also 60 degrees. Find the area of the sector AOB, the length of the minor arc AB, and the perimeter of the minor sector. Here you can choose to draw the circle. You can also choose to start working. So let me draw the circle. So if I have a circle like this, so I have 60 degrees. Here is O. And I have AB. So that's the minor, the length of what? An arc. Now in this case, the area has been given as 120 centimeters squared. Angle AOB has been given as 60 degrees. The first question is saying that you should find the area of the sector AOB. So we want the area of the sector, and you say that the area of a sector is given as theta over 360 degrees times pi r squared. But you know that the pi r squared is the area of the circle. So in this case, theta has been given, which is 60 degrees. And you also realize that they made mention of minor. Is that okay? So, or here is AOB, that's the angle here. Or the minor. If they say major, then you take 60 from to get this side. So here will be 60 over 360 times the pi r square in this case is 120 because that's the area of the circle. Is that okay? So this 0 will cancel this. And then let me go this way. So that 60 goes here 1, goes here 6, right? Then 6 goes here 1, goes into 12, 2. So that we have 20. So the area of the sector is going to be 20 centimeters squared. Is that okay? Now let's also look at, so that's the I. The length of the minor arc. So you want the length of the minor arc. So the length is given as theta over 360 degrees times 2 pi r. So our theta in this case is given as 60 over 360 times 2 times 22 over 7 times our radius. Was the radius given? There was no radius, right? Let me repeat my radius here. So if there's no radius, then you have to wait for the radius. Radius can be getting from the area. You know that area is given as pi r squared. So in this case, our area is 120. I'm talking about the area of the circle. Equals to 22 over 7 times r squared. Is that okay? So now this one, we can multiply this one by 120. So I get 847 times 120 equals to 22 r squared. Okay? So divide here by 22. Here by 22. So r squared is going to be 420 over 11. So square root on both sides. So my r is going to be 6.179 centimeters. So that's my radius. Now that I have radius, I can now go back to this thing. The length is equal to 60, which is the same as 1 over 6. 60 will go to 361 over 6 times 44 over 7 times, now our radius is 6.179. So my L will be 6.473 centimeters. Is that okay? So here, since the radius was not given, we need to work for the radius. So that's what I've done here. And you can get it from the area. Okay. Now that we have this, please know the difference between this area, the 120 given, and this 20 centimeters square. This one is the area of the sector, and this one is the area of the circle. So that's the difference. Now the last one says the perimeter. So that the perimeter is given as 2r plus L. Is that okay? The length of an arc. So P is equals to 2 times the radius, which is 6.179 plus the length of an arc, which is 6.473. So it means that our perimeter is going to give us 18.831 centimeters. Yes. So this is very simple calculation. Thank you.